that it's good to go. Now I pre-measured the height of that to make sure that the valves were not going to be above grade when they're glued in the valve box, but that they will sit comfortably in the valve box safely with the practice that I'll show you later for backfilling the valve box to ensure that no dirt gets back in it, no animals can intrude in it, and it's easy to access and maintain later on. So now we're going to build out the lateral side. I'm measuring the distance from our first station lateral to the valve. That way I know what size to cut the pipe, and then we'll add the fittings on and make the lateral connection here. Now you don't want to measure these ones exactly the same because you have the second station lateral a little bit behind the first one, and if we can keep them laying flush or flat, this is going to be a lot easier to maintain later on. If you have to come back and work with this valve at all and dig it up, you can easily see and identify which valve goes to which lateral line, and you can maintain them. You can cut them and fix them, or you can add in pressure regulators or check valves later if need be. This is just a best practice to keep things clean and tidy. Now again, you may be using a barbed end or a barbed adapter right now if you're doing polyethylene pipe. Since we're doing PVC, all the connections are going to be glued all the way through. And we're going to keep using the heavier body cement here with the primer just to keep the installation going smoothly and to ensure that we have great connection. Like I mentioned before, if you did want to use a blue glue or something that was a little bit faster setting, the lateral side is definitely the place to use that. Another tip to remember is when you're using ratchet cutters, make sure you have a sharp blade. You can sharpen your blade, but it is a very temperamental piece of equipment, and a sharp blade is going to be absolutely crucial for cutting the pipe, especially if you're using class 200, because there is a crushability factor in class 200 as it's thinner walled. So as you start to cut into those things, if you see the pipe bending too much or squeezing too much, you want to loosen up, do a slight rotation with the cutters, or replace the blade to make sure that you have a nice, clean, sharp blade for making really nice cuts. In this case, I put a brand new blade on here, so we're cutting through this Schedule 40 like butter. Another thing to remember when you're gluing is that if primer sits in a socket too long, it can actually start to eat through larger layers of pipe. So if you have a pooling of this primer, it can actually start to break down the compound of the piece of pipe. And the issue is you'll start to get pinhole leaks if that gets too thin over time. So make sure that you don't have pooling of the primer material, as it can be an issue in the system later on. Now I'm about to make the connection from the lateral line to the union on the valve. As it is now, it's going to be really tough to rotate that piece of PVC into the union when you're gluing it. But a tip that you can use is loosen up the union, and you can actually rotate the piece of the union to create a cycle turn on that piece of pipe to make sure that you get that good even coverage of solvent cement. So as you can see, I'm taking it off. I'll make the glue on there. I'll prime the piece, make sure it's good to go. Another important thing to remember when you are gluing the union onto the valve, the union nut should be on there. I like to put it on the valve side so that when I take the valve off, I can put it back on and I don't have to worry about how much distance I have between the union and the valve box, because I have enough room for the union to unscrew the nut and then pull it back towards the valve, and then the whole valve comes out as well. So this is a good practice to make sure that the nut stays with the valve and that you have room to pull it back off of the fitting when you're taking the valve off of the main line for maintenance. So here we push it on, we rotate, we make sure that we don't have any glue popping out the end of the fitting where my hand is. And then we have a nice clean gluing here, and then we can reattach that union. Make sure that the O-ring is still in place in the union, because that's what's going to be creating the seal when you tighten down this nut. And then we're going to follow the same steps for valve number 2. But like I said, we're going to cut this one at a different length to make sure that the two pipes, the two lateral pipes, stay side by side. So the reason I put the tape measure inside of the union is to measure from the depth of the socket to the piece of pipe, so that when we glue the fitting to the piece of pipe, that the piece of pipe is buried fully into the fitting and seated at the seat line. Now it's important to fully seat the piece of PVC into any fitting, because fittings are tapered, and as you push it in, you're going to get the most PVC to PVC contact when it's completely buried into the socket. Which is also why we want to cut that piece of pipe as straight as possible. The straighter we cut it, the better the seating is going to be in the PVC, and the better union and joint you're going to get with the fusion of the two pieces of plastic. Something to remember here when you're gluing the fittings in is to make sure that the glue is the proper viscosity. If you have any clumping or any highly thinned glue, make sure that you replace it and you start with a fresh can. The worst thing that you can do is go through an entire project with old glue that is not going to create as good of a connection as a new bottle of glue, and then have failures down the road system-wide. I've utilized the blue quick daubers, which the can comes with a built-in dauber, but these are nice because they create an instant seal when you put them into the jar, and it's also easy access and helpful for rapidly gluing and doing a big job like this. Once you've made sure that that O-ring is in place and you seal the union back up, it's time to connect the wiring to the valves. So I'm taping the wiring to the side of the valve manifold just to make sure that the wiring stays up on top of the valves when we backfill with gravel. We don't want it to get buried underneath the valve box or underneath the gravel, so we'll keep it right at the top, and we'll just do a little tape on the inlet side of the main line to just keep the wire accessible for us. So now that we have our wire in place, we have to wire it into the valves, and to access the wires on that fresh cut, use something sharp to cut open the sheeting on the wire so that you can pull back the outer jacketing. Then you'll find a little white string inside of all of the wires. This can help you pull down and cut open the jacketing of the wire. So the area where you cut the wire, it's important to cut back any excess wire that was at the tip of that where you cut the jacketing back, because if you accidentally nicked a wire, that can be an issue in your system forever and ever. Water intrusion into the wires will create issues with communication. It can cause shorting and it can cause system failure. So it's important to make sure that you have clean wires. As you can see, I just cut it back to where I had used my sharp blade to cut back the jacketing, and now we have good wires that were cleanly exposed using the wire jacket cutting string. And we'll expose our white wire for the common, and we'll use the green wire and the yellow wire for this valve manifold to wire back to the controller. Then strip each one of the wires back about 3/4 of an inch to give yourself enough room to make the connection with the valve wire. Here on the valve wire, you're going to have 2 wires coming out of each solenoid. One will go to the common and one will go to the station terminal in the controller. It doesn't matter which one when you're talking about AC control. There's no polarity in AC that would cause this not to work correctly. So choose one of the wires from each of the valves, put them together, and wire them together with the white wire from your multi-strand cable. These are sometimes called the neutral wire or the common wire. If you're installing a DC or battery operated controller, You're going to need to follow the polarity on the DC latching solenoid. One's red and one's black to make sure that it operates correctly. So get all your common wires together in a bundle. Some people will pre-twist. Some people like to use the wire nut to twist. In this case, I'm going to pre-twist, and then we're going to add the wire nut onto the cable. I cut it there so that every wire is the same distance from where the coating is cut to the end of the wire connection. We're going to be using DBOB wire connectors. These are waterproof connectors from 3M. And we want to make sure that when we put the wire nut on, we have a good solid connection where all of the wires are touching and well fastened inside of the connector. Now we're going to take and we're going to wire the valve on the right to the green wire and the valve at the bottom of the screen to the left to the yellow wire. You'll see that I pre-twisted the solenoid wire as it's a multi-fiber stranded wire. I twist it to make sure that it's more of a solid connection before you twist it to the station wire going back to the controller. Again, you'll see that the insulated coating is cut back to the same length on each one, and I cut the tip off to make sure that they were consistent. Now we'll twist on the wire nut and give it a nice vigorous twist to make sure it's nice and tight on those wires. We'll grab the wire nut and try and pull the wires out to make sure that they are fastened securely in the connector. And we'll do the same thing here for the yellow wire that's going back to the controller, and that is the lower valve on the screen. So again, in conclusion, to sum that back up, one wire from each solenoid is combined together and wired onto the common wire, which is the white wire in this case, and the other wire on the solenoid goes to the station terminal on the controller. So one wire from each solenoid is together. The other wire on the solenoid goes to its own wire lead back to the controller. So now that we've double checked to make sure all of our connections are nice and tight, we have our yellow wire, our green wire, and our common wire. We'll check at the controller to make sure the communication is good, and then we'll come back and we'll add our waterproof connectors, as you see in this scene. So the blue tube is filled with a waterproofing gel that makes sure that this connection is watertight once applied and stuck all the way to the bottom of the tubing. There are little wings on the wire nut that line up to grooves inside of the connection tube. Line those up and then push that connection all the way to the bottom of the waterproofing container. If it becomes too difficult to push it down using just the wires, you can use an external source like a landscape flag or a thin piece of sturdy wire. You'll see looking in the top here that the gel has covered all of the wire and wire connection, and it's now waterproof. When you have the wires in place, close the lid, creating a tension relief to make sure that that nut does not come back out of the tubing. Make sure it snaps on both sides and creates a tension relief on the wires that will prevent those from coming back out. Repeat this step for all three of the connectors in this valve manifold. You'll see in this case that it was too difficult to push the nut all the way to the bottom with just the wires, so I've used a landscape flag to push it down the rest of the way. You don't want to use something that's too big, like a screwdriver, that will actually pull the gel back out of the tubing and render it non-waterproof. So you'll see that the nut's all the way to the bottom on both of those, and we'll repeat the process for the yellow wire. So we'll use that landscape flag again to make sure that we can get it all the way down to the bottom, creating a good waterproof seal. Snap the cap on the top, create tension relief on the wire nut, It's clicked in place. It's not coming out. And we have a good waterproof connection on all 3 connections here. As you can see, we got the nut all the way to the bottom on all 3, and we're good to move on. You'll see here is the bleed screw on the valve. This is a way that we can manually activate the valve, as well as a 1/4 turn of the solenoid. Either of these options are good for manually bleeding the valve to make sure that the water is flowing properly through the system and that we are flushed on all of the lines before we put the sprinklers on. So we've tested both of them. Water flows cleanly through. They activate, they deactivate, they close and open perfectly. And we are good to put the valve box on the manifold now. So we'll bring the wiring back up to the top of the manifold here so that it is away from all of the gravel that we'll be putting in the bottom of the box. We're going to use a combination that I like that includes brick support as well as landscape fabric to prevent root intrusion and gopher or pest intrusion, and then backfilled with gravel to ensure that it has good drainage in the bottom of the valve box. Now we'll get the bricks laid, the valve box on, the gravel backfill, and your valve manifold is complete. Thanks for watching. I hope this was helpful to go through a more in-depth process of the valve manifold installation.